Welcome to this beginner tutorial into basic AI. Let's get into it. So here we are in Unreal Engine 4, version 4.26 if you want to follow along. And what we have set up for here today is just basically a first-person template with for me, a child of the first-person character. So just first-person character will do fine for you if you want to follow along. I've created a specific map just for this case. And what we want to do today is a simple AI character that moves around a little bit and explain how that works and how it's done. To begin with, what I'm going to be doing is I'm going to be importing a feature content pack up here because I want to have the third person character walking around instead of a first person character. So we will be choosing a third person character here and adding it to the project. So we have it available to us. You see it has added folders for us here now for a third person character. And yeah, so basically what I want to do is take a third person BP, this character, and you drag it out into the world. This is going to be our AI in this instance. A few things about AI. A player like us have a player controller that controls whichever pawn we are currently possessing. And in many of these templates you don't actually see a player controller because they haven't made a specific one, so you actually fall back to the default one, which if you go to settings, project settings, and you go to, where do we have modes? There, maps and modes. You can see here in the first person character game mode you have a first person character default pawn class, and you see here our player controller class, and that if it says player controller just like this, it's the default one. But you can at any point in time just create a new one if you want to and add functionality and stuff to that. But we always have a controller even if we don't see one. Now when it comes to AI, they also need to have controllers, but they are called AI controllers. I know, shocker. Anyway, so for a player controller to possess pawn and then walk around, an AI controller needs to do the same thing. They can control one pawn themselves and they can use that to walk around. And then there are some components around that as well. You can make an AI character very simple and just like code how it's supposed to work, but there are some built-in functionality to allow you to build better and more robust AI functionality, and we will be talking a little bit about that and showing off some very basic concepts about it today. Let's start off with creating an AI player controller. Now that is done by going to blueprint class like normal. And then you see we have a player controller here, but that's not quite what we want today. So if you type in AI and controller, you get to see here AI controller. If you were to create this, you could call it BP AI controller. So that's how simple it is to create an AI controller. And in here you could put in functionality that you want your controller to handle. Now, what we want to do is we want to have this third person character be controlled by an AI. So we're gonna say possess, or type in possess here under details for this character. And you can see auto possess player, auto possess AI, and then you can see placed in world, spawned, stuff like that. So placed in world, this will be fine. It will get an AI controller assigned to it. But which AI controller is it going to get assigned? Well, that sort of depends. If you open up for us, this would be the third person character, and we can see over here in the top right on the world outliner, we can edit the third person character blueprint. In here, if we have the third person character self up there marked, and then we type in controller, you can see it has an AI controller class, which is the class that will be used to possess this character if it is set up to be controlled by an AI. this is the AI controller class that it gets. So for us, if we wanted to have our AI controlled by our class that we created, we would type it in like so. And to test it out, we could type something like print AI controlled by us. And hopefully if we play this now, you should see this text up in the top left, because this character is being possessed by the controller that we created in the beginning of play. So now we have set up a custom AI controller. How is that useful to us? Well, I mean, in this example, we're not going to delve that much into it, but we're going to be showing a little bit about how you can use AI. And we're going to do a very simple thing. We're going to have this character walk around in different spots with a few intervals between those walking cycles. Now to do that, we're going to set up something that's called a behavior tree. A behavior tree you can create by right-clicking and then going to artificial intelligence and then behavior tree. And the behavior tree we will prefix with BT, so BT underscore, and let's call this third person test. And then we open that up, and this is what the behavior tree looks like. So this is where we can set up a complex network of nodes that allows our character or our AI to designate targets, to determine what it should be doing and things like that. If we were to do something very simple here, it's not called wait, so we need a selector first. We will not be delving too much into this, but we will start off by having a selector. There are a few different base nodes you have here that work in some different ways, but that's a little bit too advanced for us right now. This will basically allow us to go through a subset of tasks to do for the AI. And if we were to use wait, for example, which is a common one, and have this as our sort of fallback node, so we could have some things here to the left which would be like find the target, walk to the target, and then if it had already done those or if it didn't know what to do, then this would be the node that it falls back to. Anyway, so if we have this right here, we need to tell the third person character to let's see here, event graph is where we want to be. Let's find our begin play. There we have that one. So for our begin play, we need to tell this character that not only does it have its controller, AI controller, and control actor get pawn, not player pawn. We can use a reference to self since we are inside of the third person character, so that's the actor it's going to be controlling. Now this way we get our controller, and we need to tell the controller that it should be using this behavior tree. So run behavior tree. That means that when this character is created, it gets its controller and says run behavior tree, and then you assign it to a behavior tree asset here. So we only have one created, and this is the one that we have. Now by doing this, it will start going through its behavior tree, which is this, which isn't that advanced, but if we click it here, we can go and see that. Let's see if we can get all windows at the same time here. While the character is standing over there, it is following its behavior tree, going into the only node that it currently has available to do something from here. So that's all that does for now. So we can stop this, and let's build upon this a little bit. So this wait node is what's referred to as a task, but we can build our own tasks as well. So up here in the top you can see new task. If we click new task, this will open up for us a task blueprint sort of, which we can use in our AI behavior tree. And in this graph what we want to have is something called receive. That's not how we spell it. Execute. Event receive execute AI. This is the event that triggers when an AI is determined to perform this task. So this is the event that is being executed. And in this particular instance, we want to use this task as sort of our random walking task. We pick a destination to walk to. But this by itself won't be enough. We need to have some more things also, because the behavior tree is sort of like a part of what is needed for an AI to work. What you also have available if you go to artificial intelligence here is something called a blackboard, which is sometimes referred to as the brain of the AI. It can hold information, for example, like for our instance, where it wants to go. So if we create this, we'll name it BB as prefix for blackboard, and we will call it third person test. So that's our blackboard over there. And if we open that up, it doesn't have a lot currently available here. But what we want to do is we want to add a little bit of information here. So if we click over here on key, we can find a vector, which is what is used for determining a location in 3D space, right? We can call this a walk location, like so. And that should be everything here we need. We go save, we go back to our behavior tree. Now our behavior tree here can have its information designated now when it comes to the blackboard. So if we were to click, let's see, we click somewhere in the background, yes, we see a behavior tree here opens up on the right. We can click our blackboard third person tests and save. You can see that it opens up this section up here for our behavior tree, so we can go between these two now. Which means that we have now inserted sort of a brain to our behavior tree, which means that among other things what it has available is the walk location that we added to it. So if we go back to our task now, we should be able to do some basic logic here now. Like for example, if we right click and type in get random point in navigatable. Let's take this one, radius. So what this one does is it tries to find the location where it can go to within a certain radius, and it picks that location as its destination. So what we need to do is we need to somehow store this location down. So what we can do is we can do a set blackboard, typing is hard, and as vector. So we want to save a blackboard value as vector, because vector is the destination we're actually after to find here. And we'll just plug that in there, and we'll promote this to a variable. Call this a blackboard key, and we'll expose that one. And then for radius we can just set something like, I don't know, 2000. That should be 20 meters, I think. That's fine. Other than that, we need to get an origin. So we need to get a actor location, plug that in there, like so. And now it's happy with that. Let's go back to our content folder and rename this task. This task that we created earlier gets just this basic random name here. Well, not random, but it's not very descriptive for our tasks. So we call this BTT for as a prefix for behavior tree task, and we'll call it get random walk location, like so. we go back to our behavior tree again. And now if we were to drag off from the selector here, we can find a task here, and we can see, among other things, there are a bunch of different tasks that are available to begin with, but we also find our BTT get random walk location here. One of the things you notice now if you have this selected is that you have the blackboard key that we exposed earlier, and we can actually set this to a walk location for us. So we actually have that one as a result. So this task will supply our brain with a walk location by being executed, basically. Then we need to make use of that walk location somehow, because now we have just stored a location. So what we do then is we give some space here and we type in move to, and we have this node here which says that it wants to have a blackboard key as its value to walk towards. Then we can say that it needs to have the walk location as its walk move to location. You can see down here what its actual intent is to. If we had self actor, which is also going to be something that could technically walk to, then that's the destination here. But we're not wanting to walk to ourselves, we want to walk to the location that we have determined from earlier here. So now we have a few tasks available here. What we're gonna do what the AI is going to do is it's going to go to the selector, it's going to go from left to right and going to say, okay, get a random location, walk to the location, and then it's going to wait 5 seconds, and then this process is going to be repeating. Like so. Now all that is set up, we should go into our task here and we should go in and finish this off. A AI task can have a few different states of like reporting how well it performed. For our very simple code here, it's not going to be that advanced, but there's a node called finish executes, there we go, in which you can report how successful the task was. And for us, that's going to be directly related to this random navigatable radius, because this one will report if it found somewhere to go or not, and then this will be reported to the finish execute here, which will then be interpreted here in the behavior tree. And the success or failure of a finish execute will determine how the behavior tree will jump around in its different nodes. This particular behavior tree is so simple, it doesn't have that much functionality, so we won't be touching on it that much. But just so you have it in the back of your mind when we come back to more advanced AI tutorials in the future. Now we have laid the groundworks for the AI to actually start moving around and behaving like it actually has a brain and some life in it. But this is not enough, because what we have done is we have determined that wherever we're going to go is going to be determined by the functionality of this get random point in navigatable radius. And navigatable is the key word here, because where the character can move is not something that's entirely obvious. An AI uses something that's called a nav mesh for navigational mesh, which means that it is a calculated area where it is allowed to walk. And that is determined by things like obstructions and planes to walk on and things like that. And it's very easy to get one of those in the game. All you have to do is you go up here and you type in nav, and you get some actors here. You get nav mesh bounce volume. If you drag that in, and then let's see if it has a setting for it it does not have that. Okay, so what we'll do is we'll scale this up. We'll have this volume and we'll scale it so it actually covers more or less all of the area that we can actually play around with here. And you need to make sure that not only does it cover the area by X and Y, you need to make sure that the volume also overlaps height-wise. So now you might not be able to see it that clearly, but the yellow marked lines here are representing the the volume, and the volume is covering the whole map by X and Y, but not by Z. So we'll need to scale that up a little bit as well to make sure that it does, like so. Now, to make sure that it is actually covering the ground that we want it to cover, to make sure that it has been able to navigate the area where we want it to navigate, what you can do is you press P on your keyboard, and you'll see that it'll create green areas. And the green areas are all the areas where the navigation mesh is telling the AI that this is some place I could possibly move to. So you can see some on the floor, you can see some green on top of the cubes, and things like that. So all of these are areas that the nav mesh is considering as okay places to walk to. However, there are some limitations, like for example, a nav mesh cannot just by default go from this ground level to up here. It would require some special handling to do that, but it would be able to find all of the areas on the ground level here to see as a navigatable area within the radius for our task that we created here earlier. So that part is all good and fine for now. So let's give this a try and see if it works. So we see the character standing completely still. That doesn't seem very promising. Let's go to our behavior tree. There we go. Okay, I see that I made a bad choice here. What's happening here is, let's stop this so we don't get a seizure. I was not intending to go into this for now, but since I made this mistake, might as well. A selector is sort of a picker of tasks to do and wanting to do the tasks that it can. It is sort of like a prioritization selector. So if it is doing this task, it is succeeding, it's like super happy, so it goes back up here and it says, okay, I need a new task, and it goes up here and says, okay, we'll find a new location, and it's doing it over and over again, and it doesn't actually proceed over here, because why would it do these lesser tasks when this first task that it has priority over is working fine? I actually typed in the wrong type of node to use here for this logic. So what we want is actually a sequencer, which does something in sequence, which is do this, do that, do that. Let's see if this works better. Okay, so now you see that the third person character has decided that that's a really good place to stand, and then it walks over there and it stays there for 5 seconds, and then it picks a different location and it proceeds like that. Again, this is based on the nav mesh that we have already placed out in the world, so that is the space in which he will allow himself to find a location to run to. So this is basically the basics of AI. So let's go through this a little bit by reflecting what we've done. We started off having a simple character which the player was not going to be controlling, which is the third person character in this place. We went into the third person character and we chose its default AI controller to be the specific controller that we created. Although we don't need to do this, this was what we did for this case, which would allow us to build upon the player controller's functionality. In addition to that, we created a blackboard, which is sort of the brain of the AI, which we added a walk location for it to be able to store information about where to walk. In addition to the brain, we also gave it sort of a nervous system or a behavior tree to use in conjunction with its brain to determine where to walk to, go there, and then wait. And the task that we created to determine where to walk to is one we created ourselves, which is a very simple task, which just takes the own player location, finds a random point that it can navigate to, sets that value as a blackboard key, and then says it has failed or succeeded, depending on how that went. And in our behavior tree, that key is then stored in the walk location, which is then used in the move to location variable, and that is how all of it comes together. I hope that makes sense. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you might have down below. Subscribe and share this video if you want to see more like it in the future. In the next video we will be talking a little bit about sockets and how you can use them. That is all for now.